Assalamu alaikum. Welcome to World Geography with M.Adnan. Today's tutorial is related to flood risk map by hydrology analysis. So these five factors we need for estimating the flood risk map of any area in which elevation 10%, slope 15%, land cover, land use 10%. More specific for it, we need precipitation data, which is 35%, and a stream channel. So let's be started. We open our ArcGIS. So as you can see, we already open here a DM data and the land use, land cover, and the precipitation data for it. And now we finding slope. We need to find its one tool which name as a fill. So we first use the fill tool on the DM, then we find the slope on it. This is the spatial analysis tool. We simply here give the KPK DM, and then we just go its output as a fill. Okay, so now we OK it, and it will be come out in a fill form. Then we apply on it a slope. So as you can see, when the fill has come out, now we search for the slope, and we put here the slope as and slope spatial analysis. This one we select here the fill one, and then here we just simple give its output as a slope KPK. And this is the Z factor. The Z factor is the unit of measuring of Z unit when the different from X, Y, and it's be as a default value 0. We keep it as a its default value is a 1, so we keep it as a 1, and simple OK it. Then it will be processed and we get our data. So I let it escape it. So now we estimate the flow direction with the help of fill data, which we find after the reclassification of the slope data. We reclassify it into the 5 classes, and the classes which values have a high have a less chance of flood, so that's why we give it the less number of values as a 2, and less than highest value we give it a 4, and a very less slope we give it a 10. Okay, so now we going for next to the flow direction. So we get here the flow direction spatial analysis tool, and here we keep the fill one, and we just go to there to its output has a flow direction. Okay, and we simple OK it. So we will find our flow direction, then we will be estimate flow accumulation, then after it we will be get our stream, and then we find its distance, and then we apply our final tool. 5 minutes to escape the video. So now we estimate the flow accumulation for this area. We select the flow accumulation. Wait a minute, here is a mistake in the spelling. So now it's come. Here is the flow accumulation. Now we just give it is a flow direction, and we will get our output has flow accumulation. The short form we write as a in this way, and we simple okay it. Now it will take in time, so I escape the video. So now as you can see, the flow accumulation will be done, and now we estimated from it the stream order. For the stream order we reclassify it to reclassify. So this tool we will be used for it, and this tool we select. Now we input here the flow accumulation, and here will be the values come. The values we will be get in just one value, which is the highest value in it. It's little take time. So as you can see here the values come. Now we going to the values for classify it according to the highest one. Is the highest value is wait a minute, it's open. So we give here just two values by selecting this one, and from this will be the manually. So we done it manually, and it should be from 0 to 5,000. Okay, 0 to 5,000. So this will be the value. Here we select the no data. So because we need the highest data, highest value stream order, so here we give, here you need to give the D in the capital, we give it a no data, and here we write as a 1, and here we give its output as a stream. Then we estimate the stream distance, stream kpk. So okay it, and it will be performed. So it will be reclassified. Then I let you skip the video. So viewers, as you can see, we get the stream, but it's not showing well. So I zoom it, then it will be showing, and more I zoom it, so you can see this is our stream. So now we estimate it for its distance by accumulation distance. It shows the distance from the stream. Yes, it's that spelling, accumulation distance, and we select it, and now we just here keep the stream because we need a distance from it, and the maximum distance is optional, and we not need to give it, it should be a default value. So we just give here the output path, its stream distance as a stream distance, and just simple okay it. So viewers, as you can see, the stream distance come out, but it's in the out of our area because we need to give its environment setting. So we first going to its environment setting, so that's why we do it again, Euclidean distance, and here we need stream or stream 1. So we will be select stream from simple here, the map which we make stream of kpk. Okay, and here we give its environment. First it will be lie here. So as you can see, its cell size count, but we give it to the environment place. Processing extent to has the slope kpk be given, and raster analysis also to mass layer, which will be the slope of kpk. Okay, and we give its output has a stream distance, again 1 here with this. Now just okay it, and it will be performed according to our study area. So this one we will be unchecked because this is not good, because it's going to out of our area. It's a minute, is some error in it, so I perform it again. So now we try it, because this one will be error. So we apply here simple the stream and stream map node here. Here is a stream kpk. Okay, and we also give the environment of a stream kpk1. So here is it. We give its the shapefile, and we will check is its work or not. Hope so it will be work. When we give it's a shapefile, here we save its shapefile. So here we given the shapefile, and we also give here raster analysis to shapefile. We go to the folder, and here we give the shapefile. So simple OK, and now we give its the output as stream distance. Okay. So viewers, as you can see, it's done. So now we finally do our last steps, second last step. After it will be the last. We add here our DM data for our study area, which is commonly known as KPK, the province of Pakistan. So here we will be have the DM here, KPK DM. So now just we reclassify the result which we received, and we will remove it from here because we don't need. So for the reclassifying, first we give to its reclassifying to analysis. We simply give here the DM data first. Okay, so here will be the values of it, and these values because our area is very large, so that's why it's will take in time. It's a whole province of Pakistan, and finally we will get its values. So also it will be done. Okay, so here values we will be classified according to the 5 values, and these 5 values will be on the basis of their elevation. If the elevation is the high, so its value will be less. It's just a numbers, but it represents the chance of the flood risk. So the high elevation we give the lowest number, and the lowest elevation we give the high number. So here we simple give as a 5. Okay, then we will be classified as says the low elevation of flat area, so there will be a high chance of flood. so we give it a 10, and then it will be 8, and here will be 6, and this will be 4, and this will be 2. Okay, so it will be reclassified according to this, and we will be give it to DM reclassified. Okay, so save it. This will take time, so I'll let escape the video. So viewers, here we get one mistake, so I will correct it. The mistake is that when we reclassify, we not check this box. This box will be necessary to check for according to your needed result. This change missing values and no data optional. We need to check this box. In this video we will not check, so we get the result like that. But when we also remember we need to check it, so then we get a good. So after without check you get this kind of value, which is a not good, and if you check this box, so you will get this kind of data. So okay, so I mention it, so you need to remember it. So this data we not use in it, so I remove it from here. And now we going to this for the slope keeping. So now we reclassify distance one. Here we use the distance, stream distance, which has a nearest, so this have a high chance, so we also classify it according to the 5 classes, the natural beds. And here we check this column, and now we give it a 10 and 8, 6, 4 and 2. So here give the output stream distance reclassified. Reclassify. Okay, so here we simple okay it, and it will also be performed. And after that we going to reclassify the land use land cover. And after that we will also be precipitation and the slope. Then we use these data within our last two. So let us escape this. So the distance one is also done. Okay, so these values we will get according to the 5 values. Now we doing for land use land cover reclassify. A land use land cover we give here this one, and here is already 5 values, but here will be the 0, 1 will be represent a glacier, so glacier have a less chance, is a 2. And with after glacier there is a mountain, it's also have a less chance as a 4. And after that there will be the build-up, which has a high chance as compared to this. And we will be use here the build-up, and agriculture have a most chance, so we put it to the 8. And here is the water according to that water is the most flat area, because there is a high chance 10. And we give here 6 and more 5 as agriculture, so agriculture have a more chance after the water. So what will be remaining here? I need to count it: 1, 2, 3, 4, 5, 6. Here will be the 6 values. We need to the 5, so 1 will be the change here. Okay, so here the values which have a same chance, so we give it a same number. Like a glacier and mountain have a same chance, so we give it a 2. Okay, so then the third one will be the build-up. Okay, so before it here 4th is agriculture, so here will be the 4. Vegetation has a also have a chance, but less than the mountain and the glacier one, so we will give it's a 4. So these will be our sequence completed. The 8 will be for agriculture, and after agriculture will be the built-up area, and after the built-up area there will be the lowest chance for the this here, wait a minute, we give the third has a, this is the water, because water has a high chance, then after it agricultural land, then after it a build up, then after it forest area, vegetation, and then after it will be the mountain and glaciers part. Okay, so it will be done. Now we're going to change missing values, and here will be, we go to it's land use, land cover, reclassify. Okay, and here we save it, and here we okay, so it will be performed according to our land use, land cover. Then we will be remaining precipitation and the slope one. So as you can see, it will be done. We will get in the 5 values. Now we apply for the precipitation, which will be in the 5 values. Commonly we select the precipitation and classify it to the 5 values. Okay, and simple here keep, and the highest precipitation have a highest chance, so we will give it's the lowest precipitation have low chance, 4, 6, 8 and 10. Okay, and here will be the, we check it, change the missing values, or here we give the precipitation, reclassify, it will be done, and simple okay it's okay. So these values will be compared, and furthermore, so it's well done. Now we also get our other data, we will be unchecked, so we easily get that one. Okay, so now finally we get a slope data for it, and slope we open here, the slope. So here will be the slope kpk, and here we need to wait for it because it's a lengthy heavy data for it. So as you can see, the value is in the 9, but we need it to the 5. We classify it to the 5. It's almost the little bit resemblance, so natural brackets values, but if it's in the, we give it in an equal interval, so it will be like that. Okay, so we give it in the equal interval, and we give it the 5 values. So now we select it, change missing. Okay, and as I said, the lowest slope have a high chance because it's a flat area, and we give it the values like that, 4 and 2 here. Now we just going to the reclassify it according slope, reclassify, slope reclassify. Okay, yes, here we will be go, and it's finally will be done. So after that we will be apply a final over tool, and let us escape it. So as you can see, here is slope 2 data, because this one we also forget to check the box, so we remove it from here, and we will get here the correct data. Now we just apply our final tool, so we will be check which data we need, which data we don't need. So I uncheck all other files which we not need, this we not need, and this we also not need, precipitation is also we will classify and we will be remove it from here for better use. We remove these things because we not need it. So now I just have a 5 files, 1 2 3 4 and 5. Okay, now we open our theme of this work. Elevation 10%, slope 15%, land use 10 and 35 and 30. So here we open it. Wait a minute, here a tool is open, so we close it and we also close it. Now the tool we need, that is the wattage sum. Wattage sum tool, and here we will get it, and now we simple apply here with the sequence dm, and after dm we will be dm slope and then use land cover, slope, land use land cover, I think precipitation is here, land use land cover, precipitation and channel 1. And stream distance here. So here will be the weight. The weight we will be given for, as I'm showing, the dm will be at 10%, so we will be write it will be in the decimal. So because you can write 0 or you not can write 0, when it multiply to 100, so it will be the 10. So next we give here a slope will be 15%, so we will be write 0.15. okay, and here will be the land use land cover, which will be the, I think land use land cover 10% and precipitation 35%, 10 to 35%, 10 to 0.10 and 35%, 0.35%. okay, or and this will be the 30%, 0.30. so all these will be done. We okay it, as again I'm showing to you. Okay, so this will be done. Now just complete it and we give this output, and it will be our flood risk map. Flood risk map KPK. okay, and simple IOKH, and now it will be run, and I just let it escape it. So as you can see, viewers, our map is done, and so the highest value will be represent high risk of a flood. So this area will be cause the high risk for the flood, because it depends on the precipitation. As we check the precipitation, here will be the high, because where the precipitation rainfall is very, so there will be a risk for the flood. So the highest value represent the highest chance for the flooding. So I hope so this tutorial will help you in your estimating flood risk areas according to the hydrology, and it's very easy and will be accessible. So as you can see, this area will be the mountainous regions, so there will be the less chance, and this will be the flat area near to the water, and it have a high chance. So I hope so this tutorial will help you. Thanks for watching. For more informative videos, you need to subscribe to our channel. Thank you so much.